Okay folks, we're going to go through how we can work out the answers to the questions on the previous slide. We've been asked in the first part to work out the total resistance of this series circuit. Now we already know that the total resistance for series RT is just R1 plus R2. So in this case that's simply 9 plus 15, which is 24 ohms. So far, so good. Okay, the next step is to work out what's the current drawn from the supply. Well, we know that the voltage is 12 volts, and we now know that the resistance is 24 ohms, so we just use V equals IR. V we know is 12, I is what we're trying to work out, and R we've just worked out is 24. So I then becomes V divided by R, so 12 divided by 24 is 0.5 amps. Which leads us on to the third part of the question, the voltage across the resistor and across the bulb. So we'll do the resistor first. We know that it's got a resistance of 9 ohms because we're told that all the way back here. We also know that the current flowing through the circuit is 0.5 amps. Now because this is a series circuit, that current will be the same everywhere, so we just use V equals IR again. Where now we know that I is 0.5, and we know that R is 9, so we get 4.5 volts. Now we can do the same thing again for the bulb, which we know has 15 ohms of resistance. It's still going to have that 0.5 amps because it's in series with the resistor, so V equals IR equals 0.5 times 15. Half of 15 is 7.5 volts. And what we should find at the end of this is if we add 4.5 volts to 7.5 volts, what we get is 12 volts, which if we look all the way back at the start, is what our supply voltage was. So in a series circuit, the voltages across the individual components add up to the supply voltage.